This conference will now be recorded.
Okay. So before going into the actual demo, right? So let's say I'll give introduction of myself. My name is Rudra, and I've been working in this particular VLSI industry for the complete backend. So that means I've covered synthesis, constraint development, physical design, and sign-off STAs as well. Okay, and we have been working for multiple blocks, and here I've been working here for nearly 2 to 3 years. So okay, that means like it's like a part time. So even if you see me in future, let's say like we don't know each other. Okay, because it's against some policies where no one wants to give their real identities. So the company names and everything, we will not share it. Okay, please don't ask us that info. Okay, so now what is VLSI? That is full form. Very large scale integration is a full form of VLSI. So what is VLSI? So you're going to be having, let's say, like more than 10,000 or let's say 1 lakh of transistors in one particular area. So then you will be terming that as VLSI. Am I correct? Or let's say IC. First, what is an IC? Integrated circuit. That's again is a full form. So what's an IC? What's an IC? Integrated circuit. So that means, let's say, if you want your device, let's say a memory, do you want it in a bigger one or a smaller device? Bigger device or smaller device? You want memory. You want is like a smaller device, right? So that means if you normally use in your industry or let's say in your labs, you have used transistors and everything, right? So with respect to that particular transistors, can we develop a memory device? We can develop it, right? So internal of that particular memory is what you will be finding is like transistors, everything. So you, based on that particular working, you will be adjusting that particular connections and so. Okay, so instead of having that particular bigger complexity device, so we want is like a smaller one. So for that particular smaller, we have used is like ICs. Okay, that means in one particular smaller area, we are going to be integrating that particular multiple transistors. Okay, either we can use NMOS or PMOS or CMOS or transistors, anything we can be able to use it to get it integrated. Okay, so that means our technology node. Okay, here comes is like technology node. So based on that only we will be having this particular IC terminologies. Okay, or let's say number of transistors in one particular area. Based on that we have different categories of ICs, that is like LSI, MSI, VLSI, all that you have heard about it in your engineering. Yes, no, right? So it's, let's say, like multiple. So with the help of this particular IC development, what happened is like your device size start to shrink. Okay, so when you take initial phones, right? What is the size of the phone? It was like complete of palm, one palm it used to take, right? So, but nowadays what has happened? Again, it has come to that particular structure, but advancements are there internal to it. It became thinner one, and also the screen size in certain phones you can see is like 6-inch phone. Earlier it was like nearly 5.4 inch. Like that, you are seeing that particular size of that particular phone and everything got shrinked also. Even if you take your let's say LCD TVs, LED TVs, everything, it became thinner and thinner. Based on your visibility, you're making it 55 inch, 75 inch, and everything. So ideal is like 24 inch. All right. So from there to everyone, you are able to have this. So with the help of this particular ICs only, we are able to develop that particular bigger devices in smaller areas. Okay. So Now, based on the transistors integrated, you will be having LSI, MSI, sorry, it is SSI, MSI, LSI, VLSI, ULSI, GLSI, like that. The terms are going on. But still, when we talk it in general, right, our industry is termed as VLSI only. Though the number of transistors are increasing, but we still use that particular term VLSI only because it's like a global. You can modify it. Say like I'm working in a GLSI, but sometimes someone will ask, what is GLSI? Greater large scale integration. Again, you need to give an explanation. So instead of again giving multiple explanations, we have just used a term called as VLSI itself. Okay. So now in this particular VLSI, that is, we are going to be focusing on how this particular chip is going to be developed. Okay, what are the different steps we are going to be using? All that is what we are going to be using. So in this, you will be having is like some kind of support in scripting languages. Okay, you will be working in Unix environment and everything. Okay, you have done is like only OS of Windows, right? If I'm not wrong, if you would have done is like Mac OS or Windows OS. So there is one more called as Linux OS. Okay, so that is like one of our most secured one. We will try to use that particular Linux OS only instead of using Windows or Mac, Windows instead of Windows. Okay, few companies support Mac, and most we will be using is like Linux OS only. All our softwares and everything, it will be installed or used in Linux OS only. Okay, clear so far? So I haven't went much, but is this phase good or do you want me to slow down? Phase is okay. Okay. So now, when we are talking about this particular VLSI, you will be having is like two different types of flows. One is ASIC flow and the other one is SoC flow. Okay, so what is ASIC? Now you can tell me the full form. No idea? Okay. So ASIC represents application specific integrated chip. Okay, so that means the IC whichever you are going to be developing, it is used for a particular application only. So for example, when you go to some hotels or let's say when you go to some IT parks, the doors are automatically opening, right? Based on the sensor. So that is called as application specific. That means it has only one purpose. That is like it has to open the door and automatically close it. Okay, no other purpose. That means like if any other purpose I want to add it. So that means it becomes of multiple applications. Correct? So for example, when I enter in, who is entering? Scan. Okay. And based on that particular scan, again, it has to be identifying whether he is carrying any other objects. Okay. So that kind of scans. Other than that, if you are adding multiple applications to it, we call it as SoC. Okay. SoC represents system on chip. Okay, two different flow structures, application specific and system on chip. So application specific is like generally if you are working on application specific, that is like for a particular module or let's say block you will be working. So let's say for example you have your mobile phones, right? So is it of multiple applications or only single application? Multiple applications like networking, camera, what else we have, processors, mic module, audio, let's keep it like audio, video, like that we have different kinds of modules. So any questions? Okay. So it's of multiple applications or device. So is all developed by only one engineer? No. Can it be developed by one engineer? Yes, we can. But the time taken will be huge. Okay. The time to develop one particular complete SoC by one particular engineer will be used. That means based on the complexity. If it is of less complexity, single engineer will use it. Okay. So now based on that particular criticality, we will divide that particular chip into smaller blocks. And each block is of particular task. So that we call it as ASIC. Okay. Or let's say we group multiple ASICs. Does anyone have any questions? If no questions, could you mute yourself because I'm hearing some noise? I don't want to disturb others. Okay, thank you. Okay, so that means multiple applications together, it is going to be forming an SoC. Okay, so this individual, whatever blocks we are saying, right? So that will be provided to the experience. Based on the experience, either single block or multiple blocks will be handled, and you are going to be performing that particular flow. Okay, not ASIC flow completely. You will be assigned, right? You will be enrolled for an engineer. That is like you can be enrolled for physical design or you can be enrolled for STA. So only that particular task you are going to be performing. Okay, so that will be the role. So that means whichever your task is there, only focus on that. If you focus on others' task, what will happen? Your work will be fasak. Okay, so what happens? Again, you will be getting enrolled outside. Okay, so that's why focus on your first task, and after that, once you have completed, you can help others. If you have that particular helping nature, otherwise you can skip it also. No wrong in that. Okay, that's how industry is working. They say is like we are busy, but they are not busy. Okay, never rely on anyone in the future. Rely only on yourself. Gain as much as knowledge as you can. Okay, only when you want to share it, you can share it, or else you can skip it. Okay, there is no wrong because selfishness is one of the human tendencies right now. I'm not saying wrong to it. How it is getting changed. Okay, so now the difference. Okay, first I'll go with respect to the ASIC flow. Okay, so at the last I'll tell what all requirements are there, what all we will be covering and all. Okay, in this particular course duration and everything. So now please bear with my handwriting. Okay, so when we talking about ASIC flow, right? So that means I want to develop. So how many of you are good at coding? No coding. So somewhere in your engineering, you would have learned is like for 1 year or 6 months about that particular C writing, C programming, and everything. Some kind of coding you would have learned, right? So what is the first step of coding? Let's say I've given a question to you. What is the first step of coding? Given input. Okay. Yeah, I've given you the input. So what you will try to do based on that particular input? That is like internal to that particular coding. Before coding and question, there is intermediately one step. The question is like a raw idea, right? Yes or no? So that means the first, if I want to develop it, I need is like idea or specification. Okay. The first and foremost is like I need to get an idea. After getting that particular idea, what should I do? How to develop the code, right? Decide the logic. How do I write it? So some kind of a terminology called as flowchart. Yes. So you will be segregating these all requirements are there. So according to that, I need to develop it. So that kind of dividing, or let's say to know that particular, we have an highly experienced person who is going to be working architecture. Okay, architectural design. So in this particular architectural design, what this particular person is going to do is like that raw idea, whatever he get it, he will try to converge it into the requirements, exact requirements from what we can be able to develop. Can we able to develop it or not? If we are able to develop it, what is the cost of it? How many engineers might be required? So every estimation will be done by this particular architectural designer. Okay, so the complete design structure will be known to him. Okay, he will be playing a role with respect to the companies also. Okay, he will say like, okay, we can be able to provide you so and so engineers, they will be able to perform the task and they will be complete in so and so duration. So all that information will be provided by this architectural design. So once the project is successful, I got that particular project. So and next, from here it goes to the RTL designer. So here I have developed the flowchart and everything, right? So based on that particular requirements, RTL designer. So what is RTL? Guys, you are freshers or experienced? Freshers.
Register
Okay.
transfer level.
So engineering RTL terms were there, right? Uh, um, Verilog coding, VSDL, system Verilog. Yes. So all this will be developed by this. That means in the format of behavioral model, this RTL designer will try to do. Okay, so when we talk about this VLSI, right, just not knowing PD is not enough. So you should know from where what I am getting it. So if you face any issue, right, so you should consult with respect to that particular engineer. You can't rely on your team lead every time, right? So you should ask is like only that particular name and you should consult with it. So that's why you should know this particular complete ASIC flow. Okay, so developing and everything you don't need it. Okay, but you should know is like from where what input we are getting. Okay, from this particular, once I have developed the code, what is the next step you have done? Once you execute, what you will get it? Output. So that means as you are getting that exact output or not. So you have written something like test bench codes also, right? So that means verification. Okay, so here comes a term called as correct. Simulation, verification, everything will be coming. Functional verification. In this, they will try to provide or let's say create test benches in different languages and they will pass it, verify it, simulate it, verify it, and everything will happen in this particular functional verification stage. Okay, so everything here will be happening with respect to the that is behavioral coding only. Okay, next. After this particular functional verification, there comes a term called as RTL sign off. Okay, the details of RTL sign off I'll explain once this ASIC flow is completed. Okay, there will be multiple things. So then we will discuss that later. Okay, so after this particular RTL sign off, we will be having a step called as synthesis and DFT. Have you heard about DFT? What is it?
Design for testability.
Design for stability. Right, perfect. Perfect. Design for testability. So this DFT stage, few people will say it can come before synthesis, during synthesis, after synthesis. Anything is perfectly fine. Okay, but the only thing is like the before going into physical design, this DFT stage should integrate in the synthesis output. Okay, either you can write it before or during, it's perfect. Okay, now next is like your major role, that is physical design. And after this we have sign off. Because this synthesis, physical design, and sign off requires this four stages requires a separate one, so that's why I'll discuss it in few minutes. After sign off you will go it for chip, or let's say manufacturing. And after manufacturing you will do is like post silicon validation. And after post silicon validation it goes to the customer. So now let's go in what about this particular after sign off. I'll discuss about this particular post silicon validation. Okay, post silicon validation represents, so once I manufacture that particular chip, so whether it is properly working or not, again I need to verify it, because sometimes during manufacture it might damage some of the circuits. Okay, so that leads to your functional failures. So with that functional failures I cannot give it to the customer, right? So I need to verify it. So for that particular verification we have this particular post silicon validation. Okay, so they will be working completely with respect to microscopes and everything. Test it first, they will try to test it using the softwares. So once they have tested it, if they are seeing any kind of failures they have to re-alter that particular connections. Okay, and they will try to again verify it. If it is working they will provide it to customer. Otherwise if any failing is done it will be provided as a feedback to the physical design. So in that what all changes are there, that particular changes will be passed to the respective teams, either to RTL or synthesis they will pass it, and they will try to come again with a new. Okay, this iteration will be repeated. Okay, our particular chip manufacturing process also goes with multiple iterations. It is not in a single iteration. Okay, because it's not like physical building. So in simple terms, we are like civil engineers. They work in sun and we work in AC. Okay, they work with cements, we work with laptops. Okay, but the only thing is like they work only for a time duration, that is like 9 to 6 means 9 to 6, but we are 24 hours. Okay, so no time limit. I'm not frightening you, but this is the real thing. Okay, based on the salary you get, your sleepless nights will be there. Okay, right. So till here everyone is clear. Any questions, any doubts? No? Can I move forward? Online students? As offline, I am able to see it. Uh, yeah. So, the next I'll try to touch here is RTL sign off. That during the post physical design, I given a stage called a sign off, right? In that, you will be having that particular physical verification, as post layout STA, everything will be coming into that. Okay, so sign off. What is meant by sign off terminology? That is like that till that is closed, chapter closed. Okay, that we call it as sign off. That means every verification has to be done. Once if it is passed, you will close it and you will pass it to the next stages. Okay, if you want to integrate anything, you have to integrate in that and you have to verify it and you have to pass it forward. Okay, that we call it as sign off stages. Okay, so here in this particular RTL sign off, we are going to be stating is like there will be multiple algorithms which are going to be running in parallel. So one, we call it as linting. I'll use typing. So one linting, and next you will be having CLP, conformal low power, and next you will be having is SDC development, verification, everything. SDC represents, or let's say, timing constraints. Okay. Not to make you confused, I'll use some tips. Timing constraints. What else we have? Hmm. Uh, CTC, clock domain crossing, RDC, reset domain crossing, and based on the flow, RTL integration. Okay. So first is like linting. So in this particular linting stage, the code, whatever we have written, right, we have already verified it. So in this particular linting stage, the one more step of verification is like whether it can be a convertible logic or not. Okay, sometimes we have written a behavioral code which is like non-convertible to a gate. Okay, we might not be able to convert it to a proper gate logic, that is like AND gate, OR gate, off adder, full adder, any kind of combinational or sequential circuit we might not be able to convert it, then that particular code is not acceptable. Okay, so why? The reason is because whenever we are trying to develop it, a code, right, or let's say whenever we are physical design, right, we use is like gate level language. We don't want behavioral level languages. So in simple terms, y equal to a and b, it's a behavioral code. Or let's say you will have for sequential circuits, it's like always logics, right? Always at the rate, posage, neck gauge, like that you would have written it in your Xilinx tools and everything. Yes, no, okay, few would have done it. So Xilinx, or let's say for ECE background, CSE background, they might have touched it. Mostly ECE background, they will touch it. Okay, triple E, I'm not sure. CSE also, I'm not sure. Uh, you have done it, huh? You have done this coding? No, okay. So there is one particular subject like for Verilog, VHDL, developing of 4-bit adder, 2-bit adder, like that. When they have used it, they would have used this particular type of statements. Okay, for sequential logic, always at. For combinational logic, something like this, they would have used it. Okay, assign keywords and everything. Okay, so this particular statements are completely behavioral level coding. Behavioral level coding. So with this particular coding, we cannot be able to develop a chip. So this coding has to be converted to a gate level logic, gate level coding or logic. So that means this y equal to a and b will be converted to a function now. That means and 2. So this is two input AND gate. So and 2, and it will be having dot a1 of e, comma dot a2 of b, comma dot y of y. So like this it will be converted. Okay, and 2 is the reference name, u1 is the instance name, and next is like your inputs. Okay, and its connectivity, that kind of structure it will develop. So similarly for sequential circuits also, it the convergible, which particular cell it refers to, that particular type of cell it will be able to convert it. Okay, so this is what we require, gate level coding. As a physical design engineer, you will be requiring this particular gate level coding. So this linting will verify this particular behavioral code is convertible to a gate level coding or not. If it is not convertible, then it will try to give some kind of syntax errors and everything, which we need to get it resolved. Okay. Apart from that, there are multiple other algorithms also, which will be done internal to linting. So that will be done by a separate course. We are not worried about it. Okay. So that is like comes in your RTL sign off. As I said, we just know the concepts, but it is not compulsory that you have to know each and everything in depth. Okay. Knowing it is enough for us. So next is like CLP. So now tell me, do you want your mobile phones to be working for 24 hours or 12 hours? If it is working for 24 hours with gaming support, then you are the most happiest guy in the world, right? Yes. So we will try to develop that. Okay. With this particular conformal low power techniques, okay, we will try to develop our particular chip as much as possible to utilize less power. Less power means more battery backup. Okay. I'm trying to reduce the dynamic power consumption of that particular chip. So indirectly, if you have a bigger battery, then it supports for a longer duration. Okay, so like that, we will try to get this particular techniques using this. So this concept will also be covered in the course. That means not in depth, but what all requirements are there, everything will be covered. Okay, so CLP, what all techniques you have used, what are the different types of cells, how it is structurized, everything they will try to cover it in this particular course itself. Okay, next, timing constraints. So actually I forgot one thing. So when we are talking about VLSI, right, you have major three terms: power, performance, and area. Okay, this performance is alternative term as timing. Okay, power, performance, area. So PPA we say. Okay, our particular chip has to be optimized in such a way that it has to meet this particular PPA, power, performance, area. So in this power, you will be having leakage power, dynamic power, static, everything they will try to check each and every bit. Okay, and in this particular performance, the timing requirements. That means you are when you buy a phone, you are saying is like it is working at 2.4 gigahertz, right? So in that particular frequency, that whether your chip is working properly or not. Okay, if it is not working, then it leads to functional failure. So that we have to meet it. So like that, everything we will try to check here as well. And next is area. So as we said, right, our area, chip area has to be smaller. Okay, we have to reduce it. Or in that particular area, we have to introduce more and more functionality. So that will be our particular goal. Okay, as much as possible, we will try to reduce the area or we will try to introduce more functionality. Either of that will try to happen. So to mention that particular device frequencies and everything, right? So this timing constraint development team is going to do it, which is basically most companies will have RTL designer itself to do it. Okay, mostly RTL designers will also develop this particular timing constraints. If you are lucky enough, you might get it separately also. Okay, so it comes under STA team or RTL designer. Either of that particular engineer is going to be developing this particular timing constraints. Next, CDC. So in this particular CDC, what it represents is like, so let's talk about your again phone. You have camera module and you have memory module. So whatever the photos you take, it stores where? In the memory module. And again, when you click on one of the option in your camera, it displays that particular photo. So are we sure that camera and memory are they working with same frequency or different frequency? They might be working with respect to different frequencies, but the communication is there between them. Yes, between camera to memory there is a communication. So that particular communication checks also will be performed in this particular CDC. Okay, clock domain crossing, that means how I want to analyze that particular data between two different clocks. Okay, whether I need to analyze it or not to analyze it, or is there any other steps that we need to get it performed. So for this we need a knowledge about asynchronous clocks and synchronous clocks. Okay, so what is asynchronous clocks? Asynchronous clocks, what is meant by asynchronous clocks? No idea? Online students? Any guesses? Asynchronous clocks? Have you heard about PLL logics? Engineering में कुछ you have learned anything or not from engineering? Different phase and different frequency, yes. So PLL represents phase lock loop. So something like voltage controlled oscillator, some terms like oscillator, something you have learned, na? Because you need to revise a lot, man. You need to touch your engineering again for few concepts. Okay, so in this particular, okay, so I'll give in this particular case example basis. I have PLL1 and I have is like PLL2. It's not like in your device there will be multiple PLLs. So in general, your clocks or let's say your frequencies are getting provided from this particular PLLs only. That is oscillators. Okay, from oscillators it will be passed to PLL, and from PLL is what you will be getting this frequency out. Okay, that means from this particular PLL, it ensures that your clock is in proper phase. That means every cycle, heard about clock cycles? Yes. So that particular clock cycles is properly duplicated. Okay. So that means if you take second clock cycle and first clock cycle, it will be the same. Same time period, same duty cycle, everything it will be ensuring that. Okay. So that is the purpose of that particular PLL. The phase has to be maintained properly. Okay, from this particular PLL, you can generate multiple clocks. It's not like only single clock. You can generate multiple clock frequencies. So let's say one I will do is divide by 2, divide by 4, divide by 8, divide by 16. Okay, divider logic, frequency divider, or let's say time period divider, like that you can be able to see it. Okay, so this divider logic, based on that, your frequency will change, but the phase is not going to change. Phase represents, let's say, this is my time period. What is the time period here? 10. Okay, 10 is the time period. That is your actual clock. Now, the output of this particular div by 2 logic will have time period of 0 to 5. Okay, so that means exactly at this particular phase, you will be having 0. And at 2.5 it will fall, and at 5 it will raise. That means the edges will be properly mapped. Okay, and again at 2.5, 5, here 7.5 it will fall, and at 10. Okay, so this is called as same phase. The phase is not going to be changing. Okay, when you are talking about phase difference, right? So here I have a same 10 ns of frequency, or let's say time period is going to be passed. I have is like div by 2 logic. So this clocks are in phase, but when it comes to the PLL2, right, this is let's say like clock A, clock B. This clock B will be out of phase with respect to this particular PLL1. That means the edges will not be in same. There will be having a small deviation, or let's say difference. That we call it as out of phase. Okay, or let's say different phase. Okay, the frequency might be same, but the phase difference exists. I hope so. This is what the symbol you have used for phase, right? So this phase difference will exist for asynchronous clocks. For synchronous clocks, this phase difference will, let's say, it's not equal to 0. For synchronous clocks, the phase difference is equal to 0. Okay, it will be of the same phase. So when we have this particular asynchronous clock conditions, sorry, what is from 3 minutes? I couldn't understand. Did my audio cut off or video cut off? Okay, no answers. Okay, so for synchronous clock, the phase difference is equal to 0. So that means from here we can understand is like the clocks from the same PLL are synchronous or asynchronous. Same PLL, synchronous clocks. Different PLL, asynchronous clocks. Okay, because of this particular phase difference existence. So same phase is supportable by our tools. Okay, so that is only synchronous clocks are supportable by our tools. Asynchronous clocks are not supportable by our tool. Sorry. Okay. Asynchronous clocks are not supportable by our particular tools. Then we need a team, this particular team for our particular support. CDC. What this particular people will do is like they will introduce proper synchronizers and verify that. We won't do that. This particular CDC people will ensure that for that particular path, the timing verifications. Okay, so that is what this CDC is going to do it. Next, RDC, reset domain crossing. So this is again an advanced level. You don't need to touch about it. So as how we have discussed about clock domain crossing, right? So similarly, reset. What logic is used for? What is reset logic is used for? Reset. In your flip-flop, there is a reset pin, right? Based on that particular high value or low value, your reset, your flip-flop will be cleared. The value will be cleared, right? So that particular reset domain crossing. If there are multiple resets, how we need to analyze it? That's what they are going to do it. Okay. So I'll just repeat PLL. There was a question. Okay. So we have is like PLL. PLL represents phase locked loop. Okay, so that means the clocks generated from this particular PLL, that is all this particular, let's say here I'll give A, B, C, D, and here I'll give F, G, H. Okay, that is the clocks generated from this particular PLL, PLL1, A, B, C, D, all will be in sync. Okay, that means the phase difference will be equal to 0. Okay, and similarly from the clocks from PLL2, that is EFGH, will be all in sync, that is phase difference again equal to 0. Okay, but as there are from different sources, okay, clock A and clock E are from different clock sources. Okay, as there are from different sources, do we know that they are going to be having starting at the same time or might have a different time? Right, we're not sure of it. So that timing difference, that is this edge, zeroth edge, and the zeroth edge of E, let's consider this is your clock A and this is your clock E. So this edge may or may not be in sync. That means the phase difference we are not sure of it because there are from different sources. Okay, as there are from different sources, this phase difference exists. That's what we say. Phase difference is not equal to 0. As this particular phase difference is not equal to 0 and the clocks are generated from different PLL sources, we ensure that the clocks are asynchronous clocks. Okay, we consider this particular clocks are asynchronous clocks. Clear? Is this concept clear? Junaid, clear? Okay. So expecting silence as S and moving forward. So this is a this now our particular CDC team is going to be working on this particular asynchronous clock domains only. They won't work with synchronous. Synchronous is run by us. CDC will work on asynchronous clock domains. So which type of synchronous synchronizer they want to use it, they will use it. Okay, so that is again another course. So that if you want, you can enroll it also. Okay, so the next is RTL integration team. Okay, so this integration team will be used in the SoC flow. So integration, what do we mean by integration? Combining. Can I say combining? Yes or no? Multiple modules, I'm going to be making it into one particular single module. That we call it as integration. So that will be done in the SoC level of structurization. So as I said, right, we have split out. That is like separate netlist for each and every block I have given. Now again, I need to group it into one particular netlist. In SoC, it should be a single netlist. So that integration will be done by this RTL integration team. Okay. Along with that, they will try to again verify everything. Okay, linting, CDC, timing, everything they will try to verify it, and based on that, they will provide feedbacks to individual block owners. Okay, again, they have to go with their fix. Clear so far? So, okay. So, in RTL integration, so I'll give it in a pictorial representation. So, what happens is like initially, let's consider this is your SoC. So in this particular SoC, this is an architectural kind of information I have. So I have is like, I require is like camera. So let's say I'm developing a phone module. So I need is like camera module. I need a processor, memory, network. What else we have? Display, audio, video. Let's say audio and graphics, everything is required. Okay, so this is the architectural information. So that means I'm giving it to person one, engineer one, and memory and network I'm giving it to person two, processor person three, again display and audio person four. So that means I require is like four engineers to develop this particular codes. So they will try to develop individual RTL coding for one for camera module, one for memory, one for network, one for processor, display, and audio. They will create separate RTL codings. Okay. So in SoC, should it be in separate or it should be integrated into one? Integrated into one particular netlist, or let's say file. Okay, then only it becomes a complete SoC. If it is working separately, when to call what is unknown. Okay, so I need a communication between them. So for this particular communications, we need the help of this particular RTL integration team. Okay, what this RTL integration team is going to do is like they might be using, or let's say they will be using a tool name called as core tools. Okay, I'll not go in depth of it, that is again in another course. Okay, so core tools, so they will be using this particular tool, and they will ensure that this particular how the connectivity is there from one particular module to another module, they will just integrate it. Okay, and they will generate again one complete bigger RTL code. Okay, from this it will provide us like RTL code, or let's say whichever the input you have used, they will develop that particular RTL code, and again they will do that particular complete flow, that is like synthesis, physical design, timing, everything they will try to do it. Okay, so this is the RTL integration related information. Is it clear now? Okay, again they will process with the ASIC flow. Okay, can I move forward? So after this RTL sign off, which stage we have? What is the stage after RTL sign off? Synthesis and DFT. Okay, so for our understanding, again I'll split here. That is from idea to this particular RTL sign off is called as front end. Okay, so we in our VLSI flow or ASIC flow, we have two departments. One is front end, the other one is back end. So in this particular front end, as so far whatever we have observed, are we having any kind of dependency on which transistor you are using? What is the size of that particular transistor? Or let's say what is the size of the gate? Anything is there? Let's say physical information, anything we are loading? No. So every data over here is like logical information only, and also it is independent of technology. Okay, it is independent of technology, so this is called as front end. So they will be having mostly working with respect to the coding languages. Okay, so you should know about it. If you are not good about the coding languages, right, then you can come to this particular backend structure, but still you require coding language. Okay, still you require coding language, but not in that particular depth of what they are doing. We need is a separate coding. Let's say if you're good at Python, you can have that. If there is some more scripting languages which you need. Okay, that is like TCL and Unix, and in either of this you can have Python or Perl. Okay, so if you know Python, then consider that your resume is going to be filtered out in a faster process. Okay, so based on that we will be having that particular support. So next comes synthesis. Okay, in this particular synthesis is a stage between your backend and front end. Okay, this plays an intermediate role between front end and backend. That means as major support is in this particular stage for backend. Okay, so as we said, right, our behavioral code should be converted to a gate level. That conversion will happen in this particular synthesis stage. Okay, so optimizations to a certain level, everything will be happening in this particular synthesis stage itself. Okay, so in this particular stage, conversion of behavioral code to gate level coding. Okay, and at the same time it will try to ensure, okay, we can say in two statements, technology independent to technology dependent. That means our RTL code is technology independent netlist, whereas your output, synthesized output, will be your technology dependent. Okay, technology dependent netlist. That means your actual backend process is starting from here itself. Okay, so along here it will perform PPA optimizations. Okay, from this particular stage onwards, PPA optimization will start. What is PPA? Power, performance, and area. Okay, so next, internal to synthesis, again there is a flow. Okay, so it majorly when we say it's like analyze, elaborate, and compile. Okay, analyze, elaborate, and compile. So here analyze is like again ensuring that I'm verifying that particular RTL code. Whether that particular RTL code, whatever we have written out, is supportable by this particular tool version or not. Okay, so that's what this particular analyze stage is going to do. And from this particular elaborate stage, conversion will start. We can say it's like translation, and here also translation and mapping. That is like conversion. Your RTL code is going to be converted. In this particular elaborate stage, your RTL code is going to be converted into a tool dependent cells namings. Okay, intermediate conversion it will do. Okay, after this intermediate conversion, it will go to this particular compile stage. Okay, so compile is your actual conversion of your technology independent to technology dependent cases. Okay, so this flow, what all checks we are going to do? Okay, how what all inputs we are going to do? Okay, providing how to verify it. This will be covered in the course duration. Okay, so in your course, you will be starting with synthesis. Okay, synthesis, physical design, STA, basics of physical verification, all this will be covered in your course duration. Okay, and here we are going to be using tools, design compiler, how to invoke the tool, what are the different tools, how what is it purposes, what is the difference it, everything will be covered in this particular course duration itself. Design compiler is provided by Synopsys. This is the tool we are going to be covering it. And when you go to industry, you will be having about one more tool, that is cadence support, that is Genius. Okay, there is one more tool called as Genius, so that is cadence provider, and we might use that also. The flow remains the same, but only the difference is like from Synopsys to cadence is like commands will be different. Flow is same to same, there is no difference in the flow, only the difference is like the commands execution. Okay, the GUI, everything might have a small difference only, but easy to understand. Within a 1 month or so, you will be able to understand that particular tool perspective also. If you gain one of a tool with a good knowledge, then you will be able to get the second tool in an easier process. Okay, that means you need more explorations. Okay, so in this we might give you one particular project that will be first is like with respect to mentor support, you will try to do it a smaller one, mentor support one project, a smaller device, let's say any kind of basic kind of support project we will try to give you. And the second project is like we won't give you any details, only RTL code and the supportable input files we will provide you, that is also limited. Remaining everything whatever we teach you have to develop. Okay, the second project is like assignment, where you need to develop the scripts, everything you have to develop it. If you have any doubts, you can raise a question. Okay, so it's not like we are not going to give support or anything. It's like first, as much as possible, you have to try it, learn it, add the commands, add the constraints, and then you have to process it. So this assignment project will be running from synthesis to sign off. That is PD, everything you are going to be doing it as your assignment project. Okay, so this project will be a 14 nm. Okay, until and unless you ask questions from this, we are not going to be touching anything. Okay, one project will be as usual, we will be going in the flow.
Sorry, one question.
Yeah.
You said 14 nanometer?
Yes.
Okay. Okay. Thank you.
Okay, the second project will be a 14 nanometer, and that will be done by you only completely. Okay, at from a particular stage of physical design, we will share this particular project details. Okay, because there should be some concept should be known. So after knowing that particular concepts only, you can be able to develop everything. So that's why we will give some certain duration to understand our 28 nm flow, and after that you will be starting with this particular 14 nm by yourself, and you will be raising questions and everything from that. Okay, right, clear so far? Okay, so now, before going into the next concept, we'll take a break of 15 minutes and then we'll be back. So, back at 11 o'clock. Okay. Online students back from break. Shall we continue? Online available?
Okay, sir. You can
Yeah.
continue now.
Thanks. Okay. So after synthesis, we are going to be performing is which stage? Physical design. So this is the major criteria of your course. Okay. So in this particular physical design, I'll just give some highlights. Let's say you're going to be having a separate flow again. Flow. It's like first it starts with import design, floor plan, and power plan, placement, CTS. Okay, so this is the flow of your physical design. And in this, what we will be covering is like for each and every stage. Okay, that is like we call this each and every steps, right? Stages. Okay, so for each and every stage, we will cover, let's say, stage. What is the goal of that particular stage? What all inputs you will be providing? What all output files you will extract? And also sanity checks. That means like the checks which we are going to be performing pre stage and post stage. Okay, pre and post. That means before starting of that particular stage, what all checks need to be performed, and after completion of that particular stage, what all checks we are going to do. For each and every stage, we will be covering all these particular concepts. Okay, during theory also, if there is a tool which needs to be invoked, we will open the tool and also we will try to explain that particular concepts. Okay, it's not like we will touch only to theory. So during that particular theory sessions also, we will be touching as much as possible the tool perspective also. Okay, what all commands, how to extract that particular command specifications, and also we will give some assignments for related to some scripting languages. Okay, for your development we will be using all that particular skill set. Okay, so in this the tool which you are going to be using is again synopsis support ICC2. Okay, IC compiler 2 we will try to use it and provide it from synopsis. And there is one more tool, Innovus, which is provided by Cadence. Okay, either of this. So now we are going to be having only ICC2. When you go to industry, you might be working with either of the tool. Okay, so it's not like constantly you will be using only one tool. Okay, you will be having either of that particular tool. So in Synopsys, there is one more tool called as FC, Fusion Compiler. Okay, either ICC2 or Fusion compiler from Synopsys will be used. So Fusion compiler, from the term itself, it says like it is fused of multiple tools. Earlier we said, right, for synthesis we are going to be using as design compiler. So in this Fusion compiler, it is introduced. It is induced into it. So synthesis tool, physical design, STA, physical verification, everything you can be able to do it in one tool, Fusion compiler. Okay. So based on the cost of the project, they will try to decide which particular tool they want to use it. Okay. So the commands, everything remains same. Okay. But there will be slight changes again. Okay, from one tool to another tool or version to version, there will be only slight changes in that particular command execution only. Okay, everything, the flow, everything will remain the same. Okay, clear so far? Right. So I'll just touch what is what. So in import design stage, it is used for loading all the inputs and verifying. Loading the inputs and verification will be done in this particular import design stage. So what all inputs will be loaded? What are the internal information of that particular inputs? All that will be covered during your advanced classes. Okay, so from where you will get it? Okay, what happens if you miss it? So that kind of scenarios you need to analyze it. Okay, we will cover few things and we will ask you to do it. So based on your questions asked, we will try to answer that. If no questions asked, no answers given. Okay, so we want your effort also to be kept here. It's not like only one way of communication. We want is like two way of communication. Okay, so again, it goes in that particular four different categories. So here you will be loading all the inputs and verifying it. So in floor plan stage, you are going to be, now come some more terms called as your chip structures. Let's say shape of that particular design, area of that particular design, how that particular cell placement is going to be started, where the interface is going to be placed. Everything will be started from this particular floor plan stage. That means your actual flow of PD starts from your floor plan. Okay, you're going to be physically doing everything over here. Okay, this is like floor plan is one of a crucial stage, that is like creating a basement. Okay, so one civil engineer, you get a land, right? What you will try to do? Basement, right? So how many floors it goes, based on that particular floor, the basement structurization, the walls and everything, right? The separations, everything he has to be properly aligned. If one small mistake also, what will happen? Again it has to be coming from scratch, right? So that's why floor plan is one of a crucial stage. One small mistake here also, again you have to redo everything. Okay, so here the terms like die boundary or die area, IO clearance area, and this will be your core boundary. Okay, inside the boundaries, that is called as area. Okay, so die boundary or chip boundary we can say. Okay, that is the outer line structure of your complete block or chip. And next, in between this particular die boundary and core boundary is IO clearance area. So IO represents input and output. That means all the interface logics. It can be either pad or port or a pin. Everything will be placed in this particular interface lines. Okay, interface. So whenever you have any kind of logic, right, you will be having some kind of interface. So let's say for example our switchboards, there is a port, right? So input output, so one side only we can see, the internal side we cannot see it. So that internal side we call it as another terminologies based on levels. Okay, SoC, block and cell. So at SoC level we call it as pad, and at block level we'll call it as port. Yeah. Okay. 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 Pad, port, and pin. So pad is like at SoC level, port is at your block level, and pin is at your cell level. Okay, so based on the levels, so how it is structured, how the placement is going to be performed, all that also we will be discussing during our particular course durations. Okay, where we are going to be placing, who will provide that particular guidelines, all that will be covered. And the next concept is macros. So we have cells terminology, right? Inside that particular cells you have is like two categories. One is macro and the other one is standard cell. Okay, so these macros are bigger blocks or let's say complex circuits. For example, SRAMs, DRAMs, those are like commonly used circuits. So which I'll try to buy it from the vendors, or if I own it, I'll use those. So that we call it as macros, or we can say as memory circuits, IPs, all that will be coming under this particular macros. That means a complex circuit. When we talk about this particular standard cell, right, it's a simplex circuit. That is like, for example, your AND gate, OR gate, combinational sequential circuits, and also along with that, your basic circuits like your half adder, full adder, those will be coming under this particular categories. Okay, standard cells are simplex circuits and macros are complex circuits. So whenever you want to construct your home, first you will give importance to what? Planning. In that particular planning, which rooms you will give important? Bigger rooms or smaller rooms? Bigger rooms, right? Because they might occupy more power and everything. So similarly here also, in this particular floor plan stage, you will place all that particular bigger circuits. What are the bigger circuits? Macros. So how they are placed, so the guidelines of this particular macro placement, that all will be covered in this particular floor plan stages. Okay, so again, they're internal to this particular floor plan. There is a certain set of flow. That particular flow has to be followed. What happens if the flow is disturbed? That will be assignment for you. Like that, you have to try it. Okay, we won't tell it like assignment. You have to try yourself. We will go into that flow. If you disturb the flow, what will happen? If you don't place based on the guidelines, what will happen? Everything you have to try it. Okay, because you have that particular flexibility and everything, there is no restrictions. Okay, no blockages in that. Okay, so you have to try as much as possible. Okay, if you want to gain experience, we will just tell us like, if you do this, this will happen. If you try by yourself only, you will be able to get it into your heads. Okay, practical is what we depend most. So that's why I'll be frank. Okay, so this is what floor plan. Okay, next becomes your power plant. So distributing the power. So till this everyone is clear? Any doubts, any question? Okay. So the next stage is power plant. So in this we are going to be distributing that particular power in such a way that each and every cell should receive the power properly. Okay, if there is any kind of static, so here we will try to check as much as possible with respect to static only. Macro placement. So once that particular standard cell comes, whether that particular power can be distributed properly or not. Okay, if there is any failure, how to fix it? What are the different methods? Everything we will try to check it. Okay, how that particular reference scripts, either you can modify it or create it by yourself. Okay, that we will provide you guidelines. Based on that particular guidelines, you need to develop by yourself. Again, I'll tell, don't depend only on one particular view. Okay, in this particular VLSI, you should not depend only on one particular view. Sometimes you need to think around the globe also. Okay, if you go in a straight line, right, we don't want, simple to say is like, we don't want engineers like you. We want is like, think in all the ways and come up with one particular solution. Okay, so that's what we want. So power plant is not done by us. Okay, power plant, you will be getting a script, you will source it and you will analyze it. Because for power planning you need is like more and more concepts. Okay, so let's say when you talk about receiving a power to a specific room also, you have to decide that particular width of that particular wire and everything, right? If you have ACs, you cannot use the normal width wire. The width of that particular wire, everything, the supported capacity has to be changed. So that's why it depends on multiple factors. This power plan is done by a separate team. They will share you a script and you need to perform it and source it, analyze it and provide the feedback. What all changes you need, you just need to inform it to them. Okay, in this particular area, I'm saying so and so violation, we need a fix of that. Okay, so what all analysis you need, you will analyze it and you will provide a feedback. That is what your role in power plan. You're not going to be making any adjustment in that particular script. But here you have that particular flexibility because you are in a learning phase. Okay, you can be able to have it and you can be able to modify it. Okay, so the analysis and everything related to the power plant. So we say EMIR, electromigration and IR. Okay, voltage. So will be analyzed using a tool called as Red Hawk. That we don't have, or let's say in our course we don't have a support. That also you can be able to learn it. Okay, no restrictions. But currently, I'll suggest is like don't go into separate Red Hawk tool because your agenda will be changed. So let's go in our flow. Once you are good in that, after that you explore that particular tool. That's what I suggest. Okay, first anything major one task completed, then only go to the other task. If you mix both, what will happen? Full of confusions only. Okay, you will not have that particular confidence to clear an interview. Though you know the concepts, you will not have gained that particular confidence. So that's why go with one task completely, and after that you can be able to enroll to another things. Okay, so power plan, floor plan, I'll go to, once I'll complete this flow and again I'll revise that. Okay, so clear so far for everyone till here? Power plan. The next step is placement. So what is meant by placement? Generally, when you heard about placement, right? What is meant by placement? Crack interviews and sitting into the properized locations, right? So whichever you feel like which is good package for you and also near to your home location, that is what you choose, right? So similarly here also, placement means I'm going to be placing that particular standard cells now based on PPA. Okay, so placing the standard cells internal to the core area based on the PPA. That's what we are going to do. Without having more violations, with less violations is what we have prefer of start doing from this particular stage. So it goes in multiple stages over here. Okay, so what each and every stage is going to do, that is what we are going to be covering in the advanced concept. Because if I go in depth, right, for me 3 hours is not enough. Okay, because this is some kind of vast topic but limited topic. Okay, so we need is like more and more time. That in demo session we cannot be able to cover everything. We'll just give us like guidelines what we are going to do. Okay, so we will try to analyze and we will try to provide different kinds of fixes, iterate it, and then move forward. Okay, in your lab perspective is like each and every stage will be elaborated, explained. You have to get hands on it. Okay, once you get hands on, we will be able, you confirm it. Okay, if you don't raise any questions, right, if you sit ideal, we will be getting in a confirmation saying that you understood the concept, and then we will move forward. If you raise question, we will explain that in detail, and then only we will move forward. And here we want is like in labs, I'll again tell, we want your effort more. Okay, theory anyways is like whatever we teach, you are going to be learning it. But lab is not like that. As you're getting hands-on on it, you can try different, understand the commands execution, modify the commands execution, and you have to perform it. Okay, we will provide you the guidelines how you can be able to do that. So you have to try it and come up with your own flow. Okay, don't follow anyone's flow, develop your own flow. You have that particular flexibility, I'll guarantee you that. Okay, so in this particular placement stage, you are going to be placing the cells based on PPO, power, performance, and area. So optimizations, what all different optimizations are there, what all fixes it is going to do, what all fixes we can do, all that is what will be discussed in this. Okay, so the next concept is CTS. So in this particular CTS, or let's say I'll go again to the power plant. time, in this particular power plant stage, your power and ground nets are routed. That means real connections will be done in this particular power planning stage for power and ground connections. And in this particular placement stage, only virtual routing will be done. That means imaginary connections. Okay, in this particular CTS stage, so clock, if that particular clock reaches late, what will happen? Delay is increasing, what will happen?
Setup time.
You don't go in depth. So in simple, your functionality will fail. Okay, so let's say in sometimes, right, we don't want depth answers. We want is like whatever the topmost floating answer is there, that we want it. Though it's wrong also, you have to tell it. It boosts your confidence. That's it. Okay, it will again stage fear we say, right, that will be removed. Okay, so because of that particular clock is getting reached late, the functionality of that particular cell is also getting delayed, and that particular data which needs to be captured at that time, that is lost. So that leads to your functional failure. Okay, so now we have to ensure is like if my data has to be captured in that particular frequency. Okay, if that particular frequency, in that particular frequency, I need to ensure that the clock is reaching at that particular proper time. Okay, so that's what here in CTS stage we are going to be building the clock network. Building the clock network in such a way that all the sequential circuits will receive with a small deviation. Okay, with a small delay we can say. Okay, at the same time we will not pass it. Okay, we will not ensure all the sequential circuits will receive the clock at the same time. No, it's not the case. With a small delay we have to ensure that particular sequential circuits are getting receiving the clock. That's what we will ensure it over here. So here comes some terms like skew, latency, all that will be coming. Okay, so from this particular stage, as we are talking about PPA, right? From placement stage. So there is a concept required called as STA. So STA concepts also will be covered. So you can develop with this particular STA, you can also develop an SDC file also. So that's why I said in the second assignment, right, 14nm. So in that you will be developing after this particular placement stage. It will be provided to you. Okay, because mostly STA concept will be covered. So you will be start working on that particular 14nm project parallel. Okay, if it is not raised or if you are having any queries or let's say confusions, you can reach out to us anytime. Okay, so based on our free time, we will just reply you back. It's not like we are going to avoid you, but it just takes some time because we might hook up with some of the other tasks. Okay, so full form of STA is like static timing analysis. Okay, so CTS building the clock network by following that particular skew and latencies. After that comes your routing stage. In this particular routing stage, which nets are virtually routed? So in CTS stage, your clock tree is clock nets are physically routed. So which nets are virtual routed so far? Signal, right? So we have is like three categories: power, clock, and signal. Three types of nets we have. So power is getting routed at your power planning stage. At CTS stage, your clock nets will be routed. Okay, and at routing stage, your signal nets will be routed. Yes. Sorry. I'll give answers one by one now before going into routing stage. So revision of that floor plan and partitioning, that once this thing is done, I'll cover that. And next is like STA is, yes, we are going to be covering maximum STA concepts in this particular course itself. Okay, With this particular STA concept, you can be applying as your post layout STA, pre layout STAs also. Okay, synthesis STA, everything you can be able to handle it. Okay, so complete STA will be covered here as well, because PD to be working you should know as like STA concepts also. Okay, sometimes you might be working as post layout STA engineer also, PD plus post layout STA engineer. So that's why we require is like complete STA will be covered here as well. Okay, no partial, completely. Okay, yeah. Someone was raising a hand. Any question? If no question, can I move forward? Okay, expecting silence as this. So in this particular routing stage, it ensures all the nets are physically routed. Sorry, I don't carry any kind of PPTs because it's not my type. Stuck to in one concept, it's not my type. So I have is like always I'll follow one note or anything. I'll explain it there and there, here and there itself. Yes. Any nets. It can be if any nets you have skipped before, right? That nets will be having that particular physical connection done. So it goes in the process of first it will check for this particular power nets. If any of that particular connection is missing, it will perform that particular connection first. Power and ground. After that, it will ensure clock nets. If it is skipping any kind of connection, it will ensure those particular nets are also physically routed. And after that, it comes to your signal. Okay, all this particular category, it goes in this particular flow only. Why only this flow? Again, a question mark. Okay, that will be covered during your advanced. So in this particular flow, it will try to ensure all the nets are physically routed. Okay, you can be able to view it. Till this particular stage, only virtual connections, you will not be able to view it properly. It will be showing in a term called as fly lines. Okay, so from this particular stage you will be having all that particular physical. As now we have this particular nets physically connected, you will be going into the terms called as physical verification. That is in sign off we will try to touch now. Routing is the fastest stage for you. If it is completed, consider that your workload is reduced. Okay, if you have done routing, your major task is completed. Now comes the stages of sign off stages, where you will be having physical verification engineers, STA engineers. They will work and you will be relaxed. Whatever they give, you will take their feedback, roll it in, and provide it forward again. That is your task. Okay, so from here, the next stages will be sign off. So clear so far for everyone? Okay, so before going into sign off, I'll just explain about partitioning and also floor plan. So both I'm going to be mixing it out now. So what happens is like, so let's say your netlist, the info design which you're working is having is like 5 million standard cells and around like 400 macros. Okay, 5 million standard cells and 400 macros. So as that particular standard cell count is huge and also optimization needs to be performed, what will happen is like the runtime is going to be very huge. Okay, so it might take is like 4 days 5 days to complete one particular stage itself. Do we wait till that time? No, we want my device to be having less runtime. Okay, so now comes a task called as, can I break this particular design into smaller logics? That means into two different hierarchies I want to build it. Higher one and higher two. It can be, your design can be in any shape, L shape, U shape, T shape, any shape it can be present. It's not only square shape. Okay, while explaining, we use square shape or rectangular shape because it's easy to. But in your when it comes to real time scenario, it can be in any shape, L, T, U, everything. Okay, any kind of structure you can create also. So higher one and higher two, in which I want to split here is like 2 million standard cells, here 3 million standard cells. Okay, so this is called as partitioning. Okay, so first I'll try to analyze whether I can be able to complete that particular task in the given time or not. If I'm not able to complete it or if the complexity is increasing, then I'll closely, this PD engineer, whoever is having this particular complexity, will work with respect to RTL designer and they will try to split that particular netlist into two different logics. Okay, overall is one, but internally it is divided into two. Okay, so it is divided by, this is called as partitioning. Okay, so during this particular floor plan stage, he will decide what is the shape of that particular partition blocks. Higher one, how that particular shape looks, and higher two, how that particular shape looks. Okay, clear so far? And internal to this particular shape, that means I'm working on higher one, let's say. Okay, first, sorry, any questions? Okay, so I'm working on this particular higher one. So this shape will be provided by whom? By the upper engineer, right? So whoever is the top to me, he will share that particular info to me. Okay, so the info above me is SoC. So that SoC will be providing me this particular shape of the design. So internal to this particular shapes, what we need to do is like we need to place the macros first. That means the bigger circuits, whatever you have, that particular circuits you are going to be placing it. Okay, so on what guidelines it is going to be placed, that we will be discussing it during the advanced classes. Okay, guidelines on everything, how this particular shape can be created. While creating this particular shape, what all objects are getting created, how can I adjust them, or let's say how can I remove them, how can I analyze them, everything you can be able to explore. We will make you explore. Okay, clear so far? So floor plan is major thing is like you are going to be creating the shape and area, and you are going to be placing the ports, and you are going to be placing that particular macros. Okay, that is a major task. Is it clear? Did I clear your confusions? Okay. So can I move forward? Okay. So the next concept is sign off. So this is like post layout sign off. What is meant by post layout? In physical design, what you have done? What you have done in the physical design? Sorry?
Arrangement of those macros and cells and planning them according to that covered till the post that we ended at after that we went to
No paragraphs. One line statement.
we configured it according
You
to
have physically implemented your design. That means you have structurized your design. Simple, right? So paragraph statements, interview. Okay? That now we don't. Okay? So we have structurized it. So in simple statement is like I have created the layout of my chip. Okay, so that's why we say is like your physical design is like layout. So pre-layout represents synthesis stages. Post layout represents after PNR whatever we are doing, that is what we call it as post layout. Okay, clear? So this, okay. Is my voice clear now?
Yeah.
Okay. So whatever I'm trying to say is like, so let's say this is your PD. In this particular PD, you're going to be performing is layout. Okay. Before PD is called as pre-layout stages. That is your synthesis. And post-layout stages are called as your sign-off stages. Okay, we can call it as ECO cycles, we can call it as sign-off stages, and after that your post-silicon validation, everything will come into picture over there. So post-layout, where it will be having sign-off and so, whatever we have written there, right? In our ASIC flow, all that will be post-layout. Pre-layout is like before physical design, whatever we have written, front end and synthesis, that will be coming under your pre-layout structurizations. Okay, so now in this particular sign off stage, we will be handling is physical verification. This is like only post layout I'm talking. Okay, next is like STA, static timing analysis, and also power. Okay, and there will be multiple other checks also, but majorly when we say in an overall structure, we will be having physical verification, STA, power. Okay, so in this particular physical verification, based on the metal connectivities, okay, metal to metal spacing, there are some certain rules. Okay, whether that particular rules are followed properly or not, that will be performed in this particular physical verification stage. Okay, so this uses ICV tool or caliper. Okay, so here we are going to be integrating this ICV tool into ICC2 and we are going to be using it. No separate flow. Okay, integration into our ICC2 and we are going to be verifying that particular physical verification related. Next, for this particular STA, you are going to be using PT, that is prime time. Okay, so power, we will just explain it, not to. Okay, this basically uses Red Hawk. Okay, so again I'm telling physical verification, we will try to guide you how to fix them. You have to manually do it. Okay, 1 or 2 sessions we will try to cover on physical verification itself. Okay, even in the labs. So you have to gain it by yourself only because it's a manual methodology. Until and unless you explore it by yourself one by one, you will not be able to gain a complete skill. Okay, multiple iterations only you can be able to gain it. Okay, next STA. Again, we will be covering it in 1 or 2 sessions because most of the STA concepts will be same as what you're going to do it in physical design. In prime time, there will be some commands. We will make you explore of that particular commands and how to revert back into PNR flow. That is what we will try to guide you. Okay, so every guidelines, every concept will be covered. Okay, we will not going to be skipping anything. The only thing is like we want questions from you with your own trials because we will be going in one flow. If you go in only that flow, it's waste of time or waste of money. We want you to explore also at that particular parallel time. Okay, because your course, your class might be 3 hours. After 3 hours, you are free. Some people might be working. So in that particular free time, whenever you get it, open the tool, try it. Okay, theory anyone can study, but tool based on that particular exploration only you can be able to make it more. Okay, even when you go to industry, no one looks your theory. They will look for your tool perspective only. Theory only for cracking interviews. Tool to survive. Okay, clear? Right. Yes, you can watch it anytime. They will share you a particular link or so if you ask that particular admins. Okay, so understood about what all we are going to do it, tool perspective and theory and everything stuff. Any questions technical side, you can ask me. If not, I'll ask admin to join. They will ask about this particular, they will give you all that particular course details and timings, everything they will try to handle. Any technical questions?
Not exactly technical, but will you be the instructor for this course?
I'm not sure. I can't give guarantee. If I'm
Mhm.
available at the time of your start, I might start. I will be available. Otherwise, one
Okay.
of we have is like 2 to 3 trainers. So any one of the trainer will be taking.
So the for the whole course there'll be one trainer or there'll be multiple?
Yes, there will be one trainer. So only at critical times, based on their particular project criticality, 1 or 2 sessions might be swept. Okay, that
Okay.
means that particular topic will be handled by that particular trainer only. Intermediate topic, internal to topic, there will be no change in trainer.
Okay. Got it.
Okay, clear? So can I ask admin to join such that he can be able to clear? Okay, just give us 2 to 3 minutes.
So, hello everyone. I am Vaibhav. I am the manager of the institute. So, I hope the technical content and the technical clarities you have, all of you have got, because what you are going to learn, how you are going to learn, the course will progress, starting from the basics till the projects, what you are going to learn in these projects, and how it will help you for to get placed into the companies. So, all the technical aspects are clear. Yes, online students.
Yeah.
Okay, so we will not take more than 10 minutes of all of you. So I would like to have questions from your end. Are there any questions? Or before starting for the questions, I will just tell you how this course will progress and how we will be supporting you to get a job. See, basically, in this course, you will be starting with digital design, then PD basics, semiconductor fundamentals, then it comes to TCL scripting. Once you are done with TCL scripting, we will start with PD advanced. That is the projects where it will includes in the CSSTA, even timing constraints, floor plan, power plan, and many other things which will be there. But after every module, there will be evaluation test, so that you are keep revising in the basics also. Now also my batch is going on. Last Friday we received a opening for Intel. They're okay with 23 passouts, even 24 passouts also. They were having 14 requirements, out of which 9 candidates has got shortlisted for the final round. The final round will be in the next week. So when it comes to opening, we make sure that we have a pipeline of almost till August. So till August, we have a very clear picture of what companies are going to come, who are going to hire, what is the package they will be offering. The package you can expect from companies, if you go into service-based companies, it will be 3.5 to 6. If you go into product-based, it will be above 6. So After every module, there will be mock interviews. Once you clear the mock interview, we will add you to the next module. Then, after completion of the course, there will be a final mock interview, which will include everything from the start date of your course till the current syllabus that has been covered. Once you clear the mock interview, we will add you into job support group. In that job support, we will be continuously keeping the requirements. Now, even if you have done the training from 2015 or even now after completion of the training, still students are there in that group because even they get into the company, we don't remove them from the job support. They can be their job support. For example, you get 2 years experience and I put any experience requirement also, you can apply till you get a job. I will provide the placement support. Coming to, what if you are not able to clear the mock interview, either it after module or either completion of training. So if you are not able to clear the mock interviews, we will give you multiple chances. Suppose today's mock interview you are not able to clear, we will give you 5 days break, again mock interview. Still if you are not able to clear, again 5 days break, again mock interview, till you achieve at least a score of 8 out of 10. We will keep giving you the opportunities for mock interview, then we will learn. Now, once you, suppose you are in a job support group and you apply to a company. For every company, we know what is the requirements. We know what type of questions they ask. We have an entire database also. So suppose you are applying for Capgemini, then for Capgemini, we know what projects they focus on, what they are looking for in a candidate, what expertise they are looking. So corresponding to their requirements, we will have a dedicated mock interview where we will tell you what are the terms and conditions, what are the package they might offer, how to negotiate with them, as well as what are the technical things they will focus. And this will be for every company, so that your chances of selection gets increases. After doing all this also, there are still chances of rejection. So by any chance if you get rejected, it's either one time or either 4 times also. After every rejection there will be an assessment session, which will be, these all sessions will be dedicated one to one. It will not be a group. It will be a you and a expert person that we are having. He will ask you what questions has been asked in the interview, what answers you have given, was it satisfactory or not. Somewhere you have not given satisfactory answer or wrong answer, because of which you have got failed. So we will, the expert person will make sure that you should not answer those questions and how to answer in the right manner, so that that rejection chance will be rejected in the next round of interview whenever you apply to this. That's how you will be proceeding towards your selection. Yeah. Any, now, coming to our opportunities, I will give an example. Uh, in last year, there was a company who has hired the candidate from us, but and given the confirmation letter also, sorry, confirmation email that these many candidates has got selected. So they received, but official offer letter they couldn't receive. Since they couldn't receive the official offer letter, students were in the dilemma of whether am I selected or not. Still, so till they received the offer letter, there was another company came with the same openings. They applied to that company, they got selected, and they got the offer letter from the second company earlier. So they selected the second company. So from my end, even if you get selected by the company and you join the company also, I will not remove you from the group. The job support will be still there. You have to decide that shall I apply or shall not apply. It's totally up to you. Yeah. Any other queries you have? So I hope for online students also, the how the placements will go and how what is the evaluation process is clear for everyone. Yeah. So especially for online students, I will request this. Let us have a interactive session where you unmute yourself and ask your doubt. If I go to chat box, it might happen that I miss any message. So you can please unmute and let me know if there are any queries. Now, coming to how this session will progress. This will be a 6 days a week, 2 days theory, 4 days lab. In the theory, the trainer will teach you, suppose, 8 to 10 topics. Then, whatever he has done, he has shown onto the tool that 8 to 10 topics in the lab sessions of 10 days, sorry, of 4 days. 4 days lab, 2 days theory. In that 4 days, every day, 2 topics or 3 topics, the mentor will again teach you. Suppose 3 hours is the lab session. In 1 hour, he will teach you 2 topics. The remaining 2 hours, you have to practically do onto this tool. So how to log in into the tool, how to log in into the server, how to invoke the tool, everything the mentor will teach you. So this is called hands-on. So every day two topics you will do. In 4 days you also ramp up with whatever the trainer has covered. This is called as hands-on. 60% we focus on hands-on, 40% is on the training part. Yeah, is it clear now? Also, whatever session I am doing, whether you are attending online, whether you are attending offline, we are 100% okay with that. We don't have any issue. You enroll for offline, you want to do online, you take a permission from our management, which we will 100% give. You can move to online. I am not focused on how much session you are attending. Are your attendance is 90%? I'm not at all. Even if it is 10%, I am okay with it. My major role in this institute is your placements, because I and founder of the institute, Mr. Srinivas, is the point of contact for the placements. So, and we don't receive the openings from the HRs, junior HRs. Our students, since we being 2012, our students itself are working in Qualcomm, Intel, Samsung, MediaTek, Analog Devices, HCL, Wipro, as a team leads, as a managers over there. So directly approaches us. Suppose I am working as a team lead in Qualcomm. One of my team member is going to leave. I will not go to the HR and ask her to publish on LinkedIn, Facebook, everything. I will directly contact my references and I will ask like, is there any trained candidate? This is how we are getting the requirements. So we will be now. What left is the formalities like first HR communication. There where the HR will come into picture. Our compared to other institutes, our institute is getting giving preference by the companies is only because of the updated content and the in-depth training. Now, why I'm not bothered of your online, offline? Because today you are offline or even you are doing online. Because of online, suppose because of some internet connection, you get disconnected. Or even you are offline, but even if you are offline, you cannot learn everything 100%. 4 hour sessions I'm doing, everything that I thought in 4 hours, it is not possible for you to learn everything. So for online also and for offline also, once my session is done every day, after 2 hours, the session recording will be uploaded. Now this session is also getting recorded, which will be uploaded onto the portal, and we will send you that links also, where you can access this everyday session, entire training everyday session you will be able to access. Now whatever we are covering, that recordings will be available for you for 2 weeks. So within 2 weeks, if you missed anything because of internet connection or even in offline, you can again go through it and you can revise the topics. Coming to the notes, PPTs, PDFs, that will be also uploaded on your e-learning portal. Through that, you can access. Yeah. Is it clear
So,
to students also?
sorry, I have a question.
Yeah, please tell me.
So like your placement help out and everything, does that apply to international students too? I am here in US. And like so like what about my job search? How would you help with that?
Right. So since we are doing it from 2012, in every batch we have at least 4 to 5 students from US or even in UK also. And right now they are working in Accenture, AMD, Intel over there as well. So we can help you with the placement support, where through our references we will circulate your updated CV to them, and if there are any openings, that we will forward it to you.
Okay, perfect. So you will do the mock interviews and you said like one-on-one sessions if there is any rejections or anything, so that is also available to us too, right?
Yes, yes, that is also applicable to you as well.
Okay, awesome. Thank you.
Yeah. Any queries you have? Yes.
So I'm actually working a 9 to 5, and so I will be opting for, if I'm joining, then I'll be opting for an online course itself. So how will that go? Like, will it be every weekday or weekends, or
So
can you
when it
shed
comes
some light on that?
Sure, sure. So when it comes to working professionals, we have a weekend batch. It will be Saturday and Sunday, where it will be 9:30 to 1:30 will be theory, and 2:30 to 6:30 will be labs. And you will be getting the recorded sessions of all the theory sessions as well as lab sessions.
Okay. And for the online ones, will I get the license for all the tools, or
So the
like
tools
I am
are
assuming Cadence or
yeah,
yeah.
the tools are installed on server. So you will be getting the VPN credentials of our server. You can log in into our server and you can access how to log in, how to invoke the tool. Those training our mentors will provide you.
Okay, got it. Thank you.
Sure. Yeah. Any other queries?
One more question. Like, I am doing a project in Cadence Innovus. Like, is there anybody who can help me with that?
Yes, so we do have the Cadence Universe also. So we will be giving you the support as well on Cadence. So once we complete this project, we will be giving you the clarity of how the things can be done in Cadence tool also. So that even if the company is using Cadence tool, that won't be a stopping factor.
Okay, perfect. Okay,
Yeah.
awesome.
Yes, any other queries you have?
I joined half session late, so whatever he has taught, it's clear to me.
Sure.
I'm not in depth. I got an overview of what it
No
is.
issues. Even I will share you the recordings so that you can get a clarity also. You have not missed. We don't want you to miss a single minute also. That is the purpose of giving you the recordings. Yeah.
Is it like it's a complete 6.5 month package?
So basically, what happens is now suppose I have a batch of 25 students. No, in that 25 students, there might be a students who are little bit on a slower pace. Okay. So if the students are on slower pace, the 6 months will go to 6.5 or 7 months also. But if they are quick enough to learn and they are matching the wavelength of the trainer, it will take minimum 6 months.
Six
Because
months is minimum.
yeah, minimum 6 months. See, we don't go on the process of syllabus completion. We go with the process of student understanding. So if I cover a project and for you to work on project you require another 10 days time, I will not move to the next project unless until you all of at least 80% of you complete the project. Then only I will move it ahead. So whether it takes 6 months or 7 months, we are okay with that. And
And what is the timeline for the weekend batch that you mentioned?
see, basically what we do is for full week batch, after every module, we will give you a 1 week break because they are learning entire 6 days a week. So they are not getting break. For every module, we will give a 1 week break. So the duration for weekends and the full week batch is same 6 to 7 months. But there will be a break for 1 week for every after one module for full week. But that won't be applicable for weekend as they are learning only on Saturday, Sundays. Yeah.
Okay.
So when do the placements start usually in this batch?
So after completion of both the projects, we will start.
Okay, maybe after the 6 months duration, what you have told.
Right, right. See, it's
Okay.
not about when the placement starts because we have one now. I will give an example of last week. The one of the directors of all technologies has came to us. They wanted to interact with the students, and they have completed the basics. They were into project. So as he was ready to hire a candidate who was strong with basics. So on the basis of basics itself, he was okay to hire.
Okay, sir.
Yeah. So any company comes who is thorough, who wants to hire on the basics, we will forward your profile also. But we will conduct an interview to check whether you are strong with the basics or not.
Okay, sir.
Yeah. Any other queries you have? Yes, I'm just going through the WhatsApp messages. Sorry, this messages. Yeah, coming to this one. The video section there will be available for watch time. See the videos for live training sessions. It will be available for 2 weeks, and we provide you the sufficient time where you can watch at least 3 times. And the watch time limit we are putting because it should not happen that from your ID some others are accessing. So for one candidate to watch, we are giving you more than sufficient time. The tool access will be 24 by 7 through server. You can log in anytime. Also, there will be three groups created for you. One is the sorry, three no, two groups will be created for you. One is the common group where you are attending and with all the other candidates, and there will be another individual group where it will be only you and my team. Suppose why that group individual group is there, you are stuck with the tool. So in my that individual group, a tool administrator is also there. He can directly interact and he will solve the query. Also, I will be there, Mr. The director of the institute. He will be also there. So that even the mentor will be there, the assigned dedicated mentor. So that individual group will be for your one-to-one interaction with the institute as well as for your doubt clarification. Some students are not able to ask the doubts in the session. They wanted to interact individually. But after the session, if the mentor goes to next session, they won't get time. In that regards, the individual group will help. Yeah. So, do you want, Junaid, do you want me to explain the placement procedure again? Okay. Yeah. So even if it is online and offline, the timings will remain the same, 9:30 to 1:30. See, now also the online students and offline it is going parallelly. So for our online different class, we don't do like that. It's a complete parallel this one. Again, for the placement support, what we do is we make sure that till you get a job, we will provide you the placement support. We will be conducting multiple mock interviews, and even if you get rejected, we will conduct the assessment session.
It's one time offer, right?
Sorry.
One time offer. It's like we have to get placed at once. That's it. Post that we cannot attend the other placement.
No. See, I given you an example, right? The company had hired them. They got a confirmation email, but they didn't get the this one offer letter. Still, they were into the job support. Now, also, if I show you my job support, there are candidates who are 2017 working as a TL in Qualcomm AMD as well. So I will not support like only one time or two times, or even there is no restriction on number of times. You will be there in the job support. You can try for the opportunities till you are looking for opportunities. Unless until the candidate exits from the group, we will not remove. Yeah.
No, it's like suppose if there are two to three companies coming,
Huh.
and what if I can apply for all the three companies?
Suppose you get selected by the company, you applied to Capgemini, you get selected by Capgemini, okay, and you started working over there. After 3 months, Intel came. For me, from my end, there is no restriction. If you think you want to apply for them, you can apply, because at the end you have to complete the exit formalities of your current company, and then you have to. You want us to process your CV, you clear the mock interview, we will process your CV. That's how it is. Yeah.
I mean, it will be parallel, right? All the companies will be coming one
It
after the other.
it will be coming continuously. In January to this last month, we received 19 companies. We placed 54 students. And the average package for those 54 students, or I can say minimum package that we have provided, is 3.5. Yeah.
What would be the maximum package for those 54?
So the one candidate has got placed in Synopsys by BTech, and he got a package of 11 lakhs.
Okay.
Any other queries you have?
So what about the e-learning students, the schedules and the timelines?
E-learning is completely different. In e-learning, what happens is I have now the way I am recording the live sessions. For previous batch also, I have the recordings available with me for the complete course. So we will provide you module by module. So for example, initially I will provided you digital module. Once you complete the digital, you will be asking for the PD basics module. So at that time, I will conduct the evaluation and I will share you the feedback. If it is satisfactory feedback, I will give you another module also. If it is not satisfactory, we will tell you that do you want to revise or still you want the access. If you want the access because of your want to complete on early pace, that also we will provide. Now, when it comes to e-learning, It is completely learning via recorded videos. It is a self-based learning. So for self-based learning, what we do is a dedicated mentor we will allot where you're going through the videos and you're stuck at any point, you can clarify your doubts as well there. Basically, we will suggest e-learning students for e-learning course for them who are into working professional and cannot opt for the live training, because working professional they will be having their own job timings as well. So they can do that course at their own pace. Yeah.
So the placement support also stands for relearning students, right, sir?
Yes, for e-learning, those who are even e-learning, online, offline, live training also, it will be the placement support will be common for all, and the support will be in the same manner that we are providing. Here also, after digital module, there will be evaluation. In e-learning also, once you complete that module, there will be evaluation.
Yeah, I am
You mean
2013.
the module?
Yes,
So the module you're saying is the PD basics, which is there in the portal. That module or the individual components?
it will be on a module basis. Like in the in skill, when you log in, you can see digital, then PD basics, PD fundamental, like that.
Okay, sir.
Yeah.
Yeah, I am 2013 MTech passed out. What will
Okay.
be the opportunities, suppose if
Yeah.
I take the course?
See, right now there are many companies who are ready to hire the candidates with the educational gaps, like someone who is 2016, 2015 itself. I will not say there will be 100% placement opportunities, but whatever companies who are ready to hire with the educational gaps, for them I will be ready. I will be supporting you.
Okay. Actually, currently I'm also doing my PhD, but not in VLSI. I'm from communication systems background.
Yeah.
So, is there any advantage, or if I take
See,
the course?
basically, the companies will not go, or even the corporate sector will not go with what degree you are having. They want at least a BE BTech person to for VLSI industry and the skills. So even if you have PhD, right, they will
Yeah,
consider it, but they won't be giving. Someone having 1 year experience in VLSI industry, they will
yeah.
be interested to give more hike compared to PhD person. But it will you will not be starting something around 3.5 or this one, since you hold a PhD. Whatever is your current package, they will try to match that package.
Okay.
Yeah. Yeah. For even students who are having educational gaps like 14 or 17 itself, there are companies who are ready to hire with some gaps, so that when it comes to a client interview, they can show that you are as an experienced person. So they are ready to hire with the educational gaps also. Now, how in VLSI industry works, they will hire you and they will align you to a client. It might be Google, it might be Intel, it might be any other automobile companies also, where you have to clear the client interview. Once you clear the client interview, you will be working on project. That is one type of company. Second is the company who has already the clients. For example, Capgemini. In Capgemini, what happens is they already have the client Intel or any other itself. So you don't have to clear the client interview. They will take you, you will receive the offer letter from your company, that is service-based company. After 15 20 days, they will direct allot you a project. It might be Intel, it might be Qualcomm, it might be Samsung also. They will allot you a project and you will get a third party offer letter where you are working on a project of Intel via third party Capgemini, like that. So they will, by default, the clients are there. They will allot you the project, like that. It goes. Yeah. Any other queries you have? Yes. Okay. So I will be sharing my contact number also. So this is my contact number. I have added into the chat box, so you can note it down. And evening batches, Junaid, we are planning to have evening batches, but as of now, the schedule is not fixed. So what you can do is you can reach out to me on the number that I have shared. In another 2 to 3 days, we will confirm you the evening schedule also. Yeah. So for any doubts or any queries, you can reach out to me. We are starting a batch on this Wednesday. Enrollments are open till Wednesday itself. So you can confirm your sheet for this so that we can add you into the group and you can access the course also. So nearby, I will suggest you to take this course when your eighth semester. I think majority of the colleges are having 8 semesters as their internship. So you can reach out to us as an internships. Coming to the number of students per batch, we have maximum 25 students per batch. Yeah. Any other queries you have? Yeah, online student for online students, are there any study material provided? Yes, for online or offline, for all students, you will be getting a hard copies of the this one. Offline students can collect from our office. For online students, they have to send their address, and we will circulate one form in that you have to mention the address. We will share you the hard copy. We will courier you the hard copies also. See, there are many other courses. It depends on your interest. If you are interested in the front end, that is programming, you can opt for programming course, that is design and verification also. Coming to your specific preference, you can reach out to me. We can understand what is your area of interest. Based on that, I can guide you. Yeah. So by this, we will end the session over here. Thank you for giving your means 24. So when it comes to a batch size of 24, 25 students, 25 students offline. See, if I take online, you are attending from different places. So there is no term of count. 25 people cannot be attending online from one room. So for online, it depends on the strength. Yeah. So thank you for giving your time and attending the session. Still, if you have any query, please reach out to me. Either me or my team will answer your all the queries. And if your all queries are resolved, you can confirm your admission before Wednesday. Okay. Sure. Wednesday 9:30, the first session will start. So before, if you confirm your admission by today or tomorrow, we can add you into the group and we will share you the e-learning account also. Sure. Yeah. The course start date is Wednesday for both online and offline. Yes, all of you can confirm your admission today also. You can reach out to me. You can, I will share you the admission process. Pujita, you can reach out to me on your my number so that I can understand your profile about your career gap and then I can revert you.
No, I have one query. I was working in a different domain for
Hmm.
1.5 years. Does that include the processor?
Well, it depends on what project or what package you are getting. So if someone is, see, what happens is someone works into different domain. Like I will tell you, there was a candidate who was working in TCS for 4 years and he was getting a package of 8 lakhs and he wanted to switch to VLSI industry. So and he wanted a package of 12 lakhs. But now, when he started into TCS, he started with a package of 4.5. So I can consider experience when you have relevant experience. Is TCS as a system admin? He will that system administration. That experience won't help me. So the companies cannot give a hike on the experience that you are currently holding. But company will not reduce your package. Company will try to match your existing package.
Existing.
Existing package. They will try to match. But the skills if you are sitting in a batch of 25 students, you are also having the same skills, they are also having the same skills, but they are okay with 4.5 or 6, whatever the fresher package is. And if you are having some experience and you are asking for that package, there should be some additional projects that you should stand, so that the HR can tell them that I am hiring this person with this package. So you should be able, if you have some experience and you are claiming, you should be able to clear that interviews. Even many students comes to us saying, sir, I want to apply 3 years experience. In VLSI industry is only industry where 3 years experience, you get a package of at least 20 lakhs, 15 to 20 lakhs. None of the IT automation or anything will not give you that package. But here you are getting that package. So students comes to us and says, sir, I want to go as 2 years experience, I want to go 3 years experience. But for as per experience, responsibilities will also come. If you learn the skills and you tell that I want to go 3 years experience, okay, company will hire you also. Suppose you are able to clear the interview, but they will put you in the team leader position. That team leader position, will you able to justify? Will you able to lead a team handling multiple projects? It's not about the putting the experience in the CV. It is about justifying that experience also. Or else, company will come to know that it was only on paper experience. Within 2 to 3 months, they will again remove you. That's how it goes. Any other queries you have? Hybrid mode is something where we allow you to switch from online to offline as per your convenience, but with permission. Where you have to inform us that I want to attend online for from this duration to this duration. That also we allow. On top of that, even we have candidates who have enrolled for the course, but because of some personal reasons, they have taken a break of 1 month, 2 months also, and they again came. When they again came, we have added them again. Sure. You can contact me on the number that I have shared so that I can clarify your queries. You can select once you enroll for the course, there is a mode of training. There you can select offline, online, whatever the mode of training you want to select. Later also, if you want to change, you can take a permission and you can change. Any other queries you have? Sure. So we will end the session here. Still, if there are any, please reach out to me through the number that I have shared. I will share it once again. Yeah, sure. Thank you all. I'm ending the session here now.